Our next presenter is Phillippe Ailleris. He is currently with the European Space Agency as a project controller. It should be noted, though, that this presentation is undertaken as a personal work, not necessarily endorsed as research activity by ESA. Also, he's a board member of, as stated, UFODATA, but we'll just say UAP data, and is a project that advocates to utilize a large network of automated surveillance stations with sophisticated sensors to monitor the skies 24/7, looking for aerial anomalies. In 2009, Phillippe also founded the UAP Observations Reporting Scheme project that collects UAP reports from the astronomical community. And with that, Phillippe, let me turn it over to you.
Thank you, Ed, and good afternoon, everyone. I hope you won't have any problem to understand my French English, but I will try my best to be clear. So thanks also to the organization and to the organizer of this session. So I think as a sixth and last speaker, and as a logical follow-up of the previous interventions, I'm going to talk about some concrete approaches now, which will have for objective to better detect, study, and characterize the UAP phenomena, and hopefully we'll be able to better predict such events in the future. Next slide, please. All right. Having said that, I would like to start my presentation by providing a few points of general context. And I would like to underline the necessity of not only collecting UAP reports from trained observers like air crews, but also in acquiring instrumented data. And I think Ravi made the point very clear at the beginning. Of course, we are all very pleased to observe since a few months the favorable trends surrounding the UAP discourse, and we hope that this will facilitate in the future the reporting of sightings and encourage also a true scientific research. For sure, in order to make progress on learning more about the nature of UAP, there is the need to implement better data collection, not only in terms of enabling the reporting of serious observations, like air crews, but also in engaging in instrumented approaches to acquire UAP data. So such reports and data are absolutely necessary for the scientific community for engaging in research and learning about the physical characteristics of UAP. Overall, it's my opinion that different strategies and courses of actions need to be pursued in parallel in order to increase our chances of finding a solution to the UAP's challenge. Next, please. Concerning the aviation world and atmospheric science, it should be reminded that scientists had previously not paid sufficient attention to eyewitnesses' accounts, including airplane pilots, of some peculiar flashes or some giant flashes of light illuminating the sky above thunderstorms. And it is only at the end of '89 that some university researchers accidentally captured such natural phenomena, filming them on a low video camera. Since then, this research activity has really progressed to the point that a special instrument has been launched in 2018 to the International Space Station and is currently studying such phenomena from low orbit. The main point there is that I wish to make here is that air crews are good witnesses of unusual phenomena, and they should be really encouraged to report their UAP observations, as they could represent a new and important atmospheric phenomena like the sprites or something else. And I think the previous speaker also emphasized very well this point. Next, please. So about the UAP Task Force report, when I read it, I spotted the comments regarding the reticence to report UAP observations. This reminded me that in Europe, it was the same comment that was raised already 20 years ago within the Project Condign, which was a secret UFO study undertaken by the British government's defense intelligence staff between 1997 and 2000. It was a report that was released into the public domain in 2006. This project reports mention also there was evidence that airplane crews were seeing far more than they were reporting due to the fear of ridicule or also the potential effect on company business. So like the previous speaker, my important message today is that we are facing a stigma which exists since decades in the aviation world, and that it's really time now to take concrete action for mitigating it. Obviously, the justification for encouraging UAP reports should be twofold. Firstly, maintaining or improving flight safety, and secondly, related to the part of the human intellectual curiosity which seeks to extend our knowledge, leading potentially to new scientific discoveries, like in the example of the sprites. Once this topic is taken seriously, then science can move forward. Next, please. Now, I would like to propose a first important concrete action directly connected to the promotion of safe flight. I would recommend first that access is requested to a few selected aviation databases, the ones collecting information on safety incidents or special occurrence, and to extract UAP incidents and perform a thorough analysis. This would help understanding better the UAP occurrences and guide future research. Different databases exist, and we could start by selecting a few of them, like the following ones. The FAA, which has an unmanned aircraft system database, although despite the difficulties that have been mentioned by the previous speaker. It will also be useful to add the NASA database that they maintain themselves, called the Aviation Safety Reporting System. And of course, in order to complement that by having a global perspective, we should consult existing relevant databases outside America. Canada would be a good choice via the Civil Aviation Daily Occurrence Reporting System, or CADORS. And in fact, a special request could be raised towards the private company NAV Canada for accessing the report themselves. Outside North America, the United Kingdom Civil Aviation Authority and a scheme called the Mandatory Occurrence Reporting could also be included. Also, in this UAP case, access will only be possible via a special application, justifying it by the objective of maintaining or improving aviation safety. Next, please. So it is obvious for all that just the collection of good sighting reports and examining aviation database won't be sufficient. The only way to resolve this lack of understanding about UAP phenomenon is through serious scientific study. As mentioned today by Dr. Ravi, ultimately, any new research will need to engage in collecting new data going forward. Such effort should lead to a systematic collection of credible and high-quality data. Although this is a great challenge, there is also time for exiting new possibilities nowadays, and I would like to share with you now two positive developments. First, this scientific approach is much more durable than before. This is due to the rapid evolution in information and sensor technologies in terms, for example, of availability of off-the-shelf scientific instrumentation, powerful computing, sophisticated software, and ubiquitous high-speed internet access. All of this at a lower cost than before. And secondly, because I think that we have enough technologies available that dedicated and expensive systems don't necessarily have to be built. Instead, we could rely on collecting UAP data through existing systems. So I will now, for the rest of the presentation, talk about these two approaches, which in fact demonstrate that UAP can be studied with the tools of physical science. Next. To illustrate such approach, I would like to say a few words about field instrumented missions, and I was glad that the previous speaker mentioned the Hesdalen research. Since several years, and not only in Norway, but also in Italy and France and America, various civilians, associations, and few scientists attempt to detect and analyze UAP using scientific equipment and placed in the same geographical location from where UAP sightings have been reported. The project Hesdalen, located in a small Norwegian valley, is a leading example of such effort. In fact, this project represents the longest active fieldwork as it started in 1984 and is still operational nowadays. The objective being to capture data across the electromagnetic spectrum, and therefore a wide range of equipment is deployed here, as illustrated on the slide. Despite the fact that these unexplained lights have appeared at random intervals, the project has obtained throughout the year several successes of optical and radar detections. A few examples are shown. But Another point that is what we have to make clear is, in fact, the objective of this project by Norwegian scientists is to discover the physical mechanism causing the sphere of lights. And the few Norwegian researchers think that such knowledge, for example, could open the way to breakthrough technologies for lighting applications or energy sources. Next, please. So a second example that I wish to present is related to the US-based project called UFODATA that Ed has mentioned and to which I participate. The project is not yet operational, but in fact, important progress has recently been made with the building of the UAP monitoring station appearing in the picture on the side. Such station is, of course, consisting of 3 instruments, which will be able to measure many characteristics of UAP, as displayed, including visible and non-visible light spectrum, local environment factors, and others. The station will continuously run for 24 hours a day, and data will be recorded by most instruments only when an event will be detected. And of course, afterwards, several unique artificial intelligence capabilities will be used in order to reduce the false alarms. However, compared to SLALN, the UFODATA project will follow different strategies in order to increase the chances of collecting UAP data. Overall, the principle is to build a public science of UAP thanks to the deployment of a large international civilian network of automated surveillance stations that will be connected to an event data server. Next, please. As I mentioned in the introduction, I believe that different strategies are needed in parallel and that there are already existing technologies that could contribute well to the UAP research. One promising new method that I would like to present to you relates to the use of civilian Earth observation satellites and associated data. After all, the single site where we can learn the most about our planet is nowhere on Earth but high above it. The satellite images that are acquired on a continuous basis are powerful scientific tools to increase our knowledge of the environment. So one possibility is to use the civilians and governmental free open satellite data to mine for UFO data. In fact, this sounds like a very good concept, especially after I read the declaration of the former intelligence director who mentioned that UAP had been picked up by satellite imagery. And also, I have read with interest the latest FAQ from NASA, who makes a reference to such strategy now. So next part of the presentation, I will explain why I think this represents a potential promising research method for detecting and collecting hard scientific data, but what could be a potential application, and also some first ideas for databases extraction strategies. Next, please. So in order to realize the potential importance of satellite technology for UAP research, let me briefly recall the main advantage of the Earth observation satellites. In this case, I use the example of the 2 European Sentinel-2 high-resolution optical imager satellites, which are currently in orbit. So the satellite capture regularly on a regular basis the data. Second, they have an excellent precision, like up to a few meter resolutions. Third, they cover a very wide geographical zone, including areas very difficult to reach in several environments, and on a continuous basis. The archives of the satellites are kept, and mainly in order to see the environmental trends over a long time. And like in this case of this European satellite, part of the Copernicus program, the satellite data access are free. So next, please. So in parallel of these unique abilities of and benefits of Earth observation satellites, should be mentioned that during the past years, technology and satellite companies offering to scientists have increased dramatically, and the trend is going faster. The world observation data is rapidly changing due to 2 factors. On one hand, there's a huge increase of number of Earth observation satellites launched into orbit, and obviously this results in a massive increase of data collected. And on the other hand, also there are many different actors that are entering the market with many new ideas to build and put in orbit full constellation of satellites with the objective to cover an image constantly and every day across the planet. So on the other hand, in parallel of this huge increase of Earth observation data, there is a very rapid advance in the field of artificial intelligence, with now unprecedented capacities to retrieve and analyze all this collected data. So I think combining all the two together, I think this overall create an unprecedented opportunity for examining Earth observation satellite data to search for aerial anomalies, UAP, or unusual signatures. Next, please. So in order to illustrate first this concept and the potential application, I will show you first some example of optical pictures taken by the Sentinel-2 Copernicus satellites. As you can see on the screen, the main point is that flying objects like airplanes can easily be observed on pictures, as the satellites are even at an altitude of 780 kilometers, and the instrument is covering a wide swath of 290 kilometers wide. And so the shape of the object, in that case the plane, is quite clear on the images. Next, please. The rainbow image is a composite product, in fact, combining three spectral bands of the satellite, which allows reconstructing a red, green, blue false colored image. As I explained on this slide, this is in fact a single airplane, as the scaled color patterns for the moving airplane and the contrail is due, in fact, to the physical distance between the filters aboard the satellite. Next, please. The interesting thing, according to me, is that knowing the fixed altitude of a satellite and the physical distance between the different sensors on the instrument aboard the satellite allows to retrieve some relevant important parameters, like, for example, the size of the plane, which can be calculated in relation to the number of pixels on the image. The velocity and the altitude of the plane can also be derived via calculation. So to me, it seems that this could represent a potential application for UAP research, as some new specific algorithm could be built for the detection of flying phenomena in satellite optical databases and for the extraction of potential area anomalies by applying some threshold on such parameters. For example, we could detect phenomena related to the observables that have been mentioned in the previous presentation in relation to peculiar shapes, observable structures, aspect ratios of the flying phenomena, or pictures at abnormal altitudes, or reflecting some abnormal velocity. So to make the link to the aviation databases, we could even think perhaps using satellites data to first detect and characterize UAP that have had near misses with aircrafts. And even at the end, all what we have are optical photos, not spectral or any other data. This would already be a step forward, according to me. Next, please. So obviously, there will be the need to refine the algorithm searches in order to reduce the time to sift through huge Earth observation archives. I list now on this slide some first ideas that I had about spatial and time-based analysis methods that could be applied, and some logical ones, of course. And depending on how feasible and time-consuming such extracting algorithm could be, and applying artificial techniques like machine learning on them, we could, for example, going through some satellite optical archives and attempt to detect, as I said before, anomalies via threshold on some observables, or we could try to retrieve data from the same date and location of specific credible UAP event, like aircrew sighting. This could be even an aviation report or a sighting that has been identified in one of the archives of serious ufological associations reporting systems. Or perhaps we could even systematically retrieve data for same geographical area over a long stretch of time, like the Hesdalen in Norway, or any location where there's suddenly an increase of UAP activity, like around the east and west coast of America. So, perhaps a good idea is we could target location and period during special events, maybe like during a special deployment of military forces or training exercises, because apparently UAP activity seemed to increase during this period.
2 minutes.
Next, please. So in fact, we have reached the end of my presentation, and rather than summarizing what I just told you, I think I would rather bring forward those 3 complementary points. So for sure, the UAP is an enduring mystery that has been going on for even over 70 years at least, and it has relevance, as we see today, to the aviation, the military, and a lot of citizens. So I think that today we have, compared to the past decades, we have the technological capability to study it, and we have the opportunity to make progress. And at this moment, as the last point, is the UAP subject is gaining legitimacy, and the stigma is being reduced. But now it's really the evolutionary responsibility of the scientific and professional community to engage in this research opportunity. Such research which is difficult, requires proper funding and proper course of actions and strategies. Thank you. This will conclude my presentation. Thank you. And in case of any question, I'll be happy to hear. And I hope everybody understood me. Thank you.
Philippe, thank you. And most engaging, and your points spoken quite well. Definitely in comparison with my ability to speak French under the same set of topics. And I'm sure many share in that sentiment. So again, my sincere congratulations on that and appreciation. Now, let me start off with question and answers for Philippe. Please go ahead.
Hi, Philippe. This is Christopher Plain, head science writer at the Debrief. Can you hear me okay?
Very well, thank you.
Great. You gave some imaging and other examples of how satellite data might be used to add, shed some light on the mystery. Is that a proposal to use satellites that are already in service and having them retasked? Or was this a proposal for satellites dedicated to this project?
No, my proposal is, as I said before, is the tools already exist, and it will cost too much to develop new specific system as a starting point, I would say. So we have to take advantage of what is available, and there's the possibility to use already highly calibrated and very effective satellites instruments. So we should take advantage of them. And in that case, there are several databases that are already available for free. Of course, we can also contact specific satellite private companies who also have archives in order they would help, but then we'll need to pay them. But so I don't advocate for building a satellite and launching a satellite dedicated to UAP detection. Although maybe a very small satellite could be done.
So you're recommending both utilizing the databases of information that are already captured and stored
Yes.
from existing satellites, as well as potentially tasking them to specific events.
Maybe I was not clear enough. I think we have to build up algorithms to retrieve the data from the existing satellite data.
Databases.
Existing
Okay,
databases. Now, because the next step is much more expensive, and you will need much more expertise and technical abilities, time and money.
great. Thank you, sir.
Thank you.
Hi, Philippe.
Hi.
Hello?
Hello. Yeah, I hear you.
Okay, great. Really fascinating talk. Thank you. I was curious about the Sentinel-2 ESA satellite and what specifically is kind of the technical reason for the satellite doing these Earth observation images from 3 different spectral bands over time, over the course of its orbit. I'm curious to know just why it's already doing that.
The Sentinel-2, and with the optical instrumentation, was devoted to the analysis of the vegetation, in fact, especially for helping crops and to how do you say that, to understand the situation, the health status of the crops. So it's for agricultural reasons on the ground, because they can detect through the different instruments how dry is the ground, if you need water, and if you what is the health status, if you need to put more products in order to make it to improve the crops production. So it was mostly for this kind of the nature of this agriculture and for feeding people basically at the end of the day.
Yeah,
to increase the capacity.
So with the airplane and the contrail, is the fact that this is like a very white, bright object that's reflecting the entirety the reason that it's producing this effect?
Alors, if I may compare, in the past, we had these spy satellites or these defense satellites, and they were taking just pictures above specific points, a specific time. Now the satellites are evolving in a kind of following a carpet mode picture. They acquire continuously picture across this swath. So you have a huge amount of data. And of course, when they pass across areas, they will take a picture of anything that is in between. So my idea is, I mean, we could use this opportunity to try to progress in the field. Of course, the satellite is not dedicated to this kind of survey, but the advantage is they are there. You don't need to develop an instrumentation, and the data normally is available. What needs to be done is the building up of the specific algorithms and retrieving the data and analysis.
Understood. Thank you.
Thank you, Matthew.
All right, Philippe, that will finish up our time allotted for the individual speaker Q&A. And I want to thank you again. And we're going to go on to quote unquote unscheduled element to our panel. And give everybody a little bit of a background beforehand. And that is, as we've heard from all the excellent presenters, if you will, for a bit of a tawdry explanation on my part, is a simile is each one is looking at this environment of UAP through their specific wavelength in the spectrum. And when we had planning meetings relative to this special